Hello everyone, can you see my screen now?
Yes, we can.
Okay, great. So, good evening everyone. So today we're going to talk about building an AI agent using LangChain, right? So, I think in one of my previous sessions I've talked about how how I think in one session we talked about building AI agents, right? And we said that there are various ways in which you can build AI agents, various frameworks. You can build using LangChain framework. You can build using simple Crew AI for multi-AI agents. And you have different various other frameworks. Like from Microsoft, you have one framework. You have from Google, you have one more framework, and so on and so forth. So, end of the day, again, why do we need all these, right? Why do we need LangChain and all these, right? Because creating these agents and orchestrating the agent behavior, correct, requires some kind of code, and we don't want to write all that code every time we want to create an agent. Okay, it should be very simple to spin up an agent and get that agent working for us, right? Because in the industry and in real world use cases, there is not going to be one agent or two agents. There can be hundreds of agents. Okay. And in fact, the plan is most organizations, big organizations are planning to have thousands of agents, right? Now, why do these agents exist? A lot of these agents will be doing a lot of work like automation, or they can be performing workflows based activities, correct? So whatever it is, agents it should be easy to spin up agents and get them going and doing a particular piece of work. Okay. So I'll talk a little bit about LangChain since that is the topic of today's discussion. And today's topic is also about spinning up an application quickly using LangChain, correct? So an AI agentic application using LangChain. So I'll talk a little bit of theory, and then I will talk about an AI agent application which we build and which I will show you. I will also show you how we can use Langsmith and also maybe touch a little bit about LangGraph. Okay, so I'll show you how an application created using LangChain, an agent created using LangChain, can be used for tracking the agent's behavior under the hood using Langsmith. Okay, so LangGraph, again, I won't go into the depth because it is a node-based approach towards building agentic AI applications, but because it's a very big topic, and I don't think we'll have time to cover everything in LangGraphs. But Langsmith is something that is used for observability, and I'll show you that so that you can understand how you can track the agent's behavior. Okay. Um, so LangChain again, I hope my screen is visible, right? All of you can see my screen.
Yes, sir.
Yeah.
Okay, great. So LangChain is an open source library, okay, and it is a really popular way to build LLM applications. Okay, so LangChain is now 3 years old. It was 3 years ago they launched it. Just I think a few days ago, it completed the third anniversary. So recently they built a new easy to use agent that is easy to use, built on LangGraph, and it gives the agent durable execution, persistence, and more, right? So traditionally, agents used to be able to do a piece of work, but they could only do that work and nothing else, correct? So every time a new request came, it would think that the request came to it for the very first time, correct? So that became a problem because every time you uh, made a call to an agent and it got some information from an LLM or from third party sources, if we are not going to reuse that information, then it's a wasted opportunity, correct? Because again, you'll hit the LLM with the same information, correct? So that's why we introduced something called memory. Okay. And the memory is going to allow the agent to persist the state between two different calls so that the agent can be much more usable. So let me give an example. Uh, so if you think of, suppose you're going for a movie, right, with your friends, right? And all of your friends, if you want to go to a typical movie, right? Um, it will suppose what are the steps involved in going to a movie, correct? So you have to plan which movie should you go, which theater you should go, which hall you should go, which time you should go, how many friends should go, and all this stuff, right? Is it nearby your house? Everything. Let's say, you decide all this, you make a all plan, and then you say, okay, fine, you are going to the movie. But suddenly your college teacher will come and say, sorry, the exams are there, flash exams. So then you will abort that plan, correct? Now, let's say after 2 weeks, the exams are over, okay, and then you want to go back to the movie. Would you want to again do everything from scratch? No, right? So you want the agent to remember the state. So next time after 2 weeks, you say, okay, we want to continue go back to the movie. All your previous preferences should be saved. Like you wanted to go to OG, so and so hall, so and so name, and all that, right? So uh, imagine. So which one do you prefer? Can someone tell me what do you prefer? Do you want to again tell all the information from scratch, or do you want it from previous? Can someone tell me what is more preferable? You can put your
Want
chat or just unmute and just talk.
wanted from previous.
Want it from previous, right? So the point is, if you want it from previous, but if your agent does not retain the previous state, then again it has to ask you all over again, and that's not a great experience, correct? So what we do is we introduce the concept of memory, and the memory will retain all that, and you can simply say go ahead and book it again, and that's it, it does it. So that is some of the advanced things that have come up in LangChain in the recent times, and it also introduces something called middleware, which allows us to customize our agent. Okay, so what we'll do in this session is build a simple agentic application. Okay, and build on it as we explore the capabilities of the agent. So has anyone built any agent so far? Can you just unmute and speak? Built an agent? Have any experience? Anybody?
Yes, I built an support chat support agent.
Okay.
Uh, yeah,
Okay, okay. So, yeah. And what framework did you use?
for this implementation, I use NA10.
Okay, very good. Nice. So, here what we are doing it is we are using LangChain, and we are using various building blocks such as models, the messages, memory, and the tools. Okay. So we'll use the agent and enhance it with the middleware. And we will this will also let us add dynamic prompting and model selection. Okay. So one of the most important uh, thing about this new concept is it allows you to select any model. There's no dependency on the model. Okay. So that flexibility is important from the perspective of not directly coupling you to one model, right? So you can use ChatGPT, you can use Gemini, whatever, correct? Now in this session, I will also show you Langsmith and Studio visibility tool specifically for stateful agents. Okay. Now, how do you create an agent? Okay. So what we are doing is we are um, uh, trying to clone a repo, and then we'll use OpenAI API key and Langsmith. Okay, so if you can see Langsmith over here, all of you can again directly go and subscribe to Langsmith. If you can go to Google, you can click on Langsmith over here. So Langsmith is also a product of uh, you know LangChain only, where you can select a particular project and see the complete traces. Can you see this? So I'll show you shortly how you are tracking that. Okay, and so if you see this, you can actually. Has anybody used Langsmith ever? Anyone? Anyone used it? Nobody. Has anyone heard of Langsmith? Somebody who created an agent. Have you heard of Langsmith? So Langsmith is again LangChain, LangGraph, and Langsmith are three things that a lot of people get confused. So LangChain is the framework. LangGraph is the node-based architecture of for building node-based agentic AI applications, and Langsmith is the observability. Okay. Uh, this is basically used to build applications, okay, which will help us not only just build them for the sake of it, but also provide tracing for them. Okay, so I'll show an application. So this particular query, what you're seeing here, which table, right? Which table has the largest number of entries? This is a question asked to the agent, and this is giving you the complete trace. Okay, so I'll talk about it as we go along. Okay. So the next thing is the session is basically divided into uh, three parts. Okay, the first part is you will work through the basic agent demonstration by building a SQL agent in just a few lines, right? Then we will talk about LangChain agent fundamentals, okay? And thirdly, we'll talk about how we can customize the agent, okay? So if you're using middleware to add people to customization, LangChain has a new emphasis on agents with a new React agent, okay? So has anyone heard of React? What is React? Anyone? React is not like the React JS. It is REACT. 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 Anyone? Okay. React is basically stands for reasoning and acting. Okay. So React agents operate in a loop, which means that when a model receives a request, right, it does not immediately complete it. Okay. So if I show the screen here, okay, you can see in the screen, this is the React agent. Okay. So what happens is when the request comes to the model takes an action using a tool. Okay. And based on the tool returns an observation. Okay. Now, once it returns an observation, what the model says is this observation which the tool is returning? Okay. Now, I think in my previous session, I talked about an agent, having tools, the brain and the body and all that, right? I hope all of you are aware of that. The brain and the body, right? The brain is basically the LLM and the body is the tools. Are
Yes.
all of you aware of that? Do you want me
Yeah,
to
yeah.
just repeat as that?
Uh, no needed. Yeah, we are we
You're
are
aware,
very
right?
good.
Correct.
Yeah.
So basically, in this React kind of a ecosystem, what happens is the model gets the request, calls the tool, it takes observation. If it observation addresses the request, then it goes ahead and exits. Otherwise, it again makes a call to the tool to get new information, and then it sends the final result out. Okay, so that's how it works. And what we'll do in this particular thing is we'll create an agent. Okay, I'll show you the code in terms of how we are creating the agent. The agent is basically going to access a Chinook database, which is provided by LangChain. Okay, so we've taken a database provided by LangChain, and it's going to access the Chinook database and give us insightful inputs. Okay, now here we are saying the React agent is energizing reasoning and acting in language models. So reason, action, and observation is what it takes care of, and it's built with LangGraphs, right? So so here, what exactly happens in this demo application? What we're trying to do is you have Chinook, which is the music shop example database, okay, and the agent is basically so a request comes to a model, and the model has tools, and the tool that we are giving it is execute SQL, okay. So it is going to take the request from us as a user and is going to execute their database query, get the results from the database, and return the data back. So it is typically text to SQL query and SQL query back to result from the database. Okay, so we're basically talking to the database in natural language in English. Okay, so how is that facilitated? It is facilitated by the use of the model, which is calling the tool called SQL execute SQL. Okay, so if you see here carefully a little bit more in detail, so what we are trying to do is at a high level, uh, we are from the SQL database, we are importing Chinook.db, which is provided from LangChain community. And then we are creating runtime context for this. And we have a tool definition. At the rate tool basically defines a tool. Okay. So this tool that we are creating is execute underscore SQL. And this tool is basically, if you see, this is the doc string. Okay. In Python, pretty much again, execute a SQLite command and return results. Okay. So it's a doc string for that. And it is going to basically the agent is going to use this information to identify which tool should it call, correct? And this particular line, which is execute SQL command and return results, is used by the agent to call this particular tool to get the data from the database, correct? Now, obviously, of course, today, right now, we are only defining one tool, so it will obviously call that. Then runtime is equal to get underscore runtime. It's going to get the runtime context, which we defined above, of the database, correct? SQL database, you can get the runtime context, and is going to call the runtime.context.db. Okay. Um, so And then finally it returns a db.run, which is the query which is coming in from the user, correct? The user is as the query. Now you also have a system prompt. If you can see the system prompt, you are a careful SQL analyst. The rules involve think step by step. Okay. When you need data, call the tool SQL execute underscore SQL. So this is a system prompt that is sent to the agent. Okay. So the agent should know what it's supposed to do. Okay. So although it has a brain and a body, the brain is LLM and the body is the tools, the brain still needs to know what exactly is it supposed to do. What is its job? Okay. So here what we are saying is this is a system prompt. You are a careful SQLite analyst. Okay. The rules are think step by step. Okay. When you need data, call the tool SQL execute underscore SQL, which I showed you is the tool with one select query. Okay. Read only query, no insert, update, delete, alter, drop, and all these things. Can someone tell me why do we have this particular thing line in the system prompt? Anyone? Can anyone tell me why do we have this line? Read only, no insert, update, delete, alter. Reason, anyone? Nobody? So reason is that you don't want the LLM to create any of these insert, update, delete, alter queries which can impact the database, correct? So what we are saying is the LLM is dynamically creating an SQL query, and if that query is any one of these altering database altering queries, it will corrupt the database, correct? So that's why we don't have that. Okay. Next, we are saying limit to 5 rows of output unless the user explicitly asks otherwise. Okay. So we're saying just limit it to 5 rows because we don't want the whole database to be pulled out. So the tool returns error. Okay, that means if I'm calling the tool, but the tool is giving an error, which means revise the SQL and try it again. Okay. Now prefer explicit column lists. Okay, which means give the exact column names instead of select star. So why is that? Because we don't want the entire database to come out. And finally, this is how we are creating the agent. Agent is equal to create underscore agent. Model is equal to OpenAI GPT-5. This is the model we are using. These are the tools. There's only one tool, which is execute underscore SQL. The system prompt is what we gave here system, and the context schema is equal to runtime context. So this is the runtime context, and we are taking the SQL database from that context. So here is on the right side is how we are making a call to the question. We are asking a question called which table has the largest number of entries. Okay. So when we ask that question, it is going through the agent stream. Okay, agent stream is basically going to say, if I'm making calls, I want it to be continuously streaming the responses coming from the agent so that I can display. Okay. So what we'll do is I'll show you the code. Okay. Any questions still here? Anyone? Yeah. So here, what I'm showing you is I'll just zoom in. Okay. So on the left side, if you see, there is this file called LangChain underscore LangChain one underscore code. Okay. So I'll minimize that. We don't need that. On this side, also I'll remove this. And over here, if you see, this is the LangChain code, which we are building an agent, a simple agent. What the agent is going to do is that we have a database. Okay. I'll show you the database file on the left side. If you see there's chinook.db, correct? So it is some kind of format that we don't know. We cannot open it directly. Okay. So we also don't know what is there in that chinook.db, but we know that it consists of music data. Okay. Now, what we are going to do is build a SQL agent fast. Okay. The SQL agent can query and analyze SQLite databases. So that's basically an SQLite database. Okay. That information is known. But what contents are there in that? We don't know. Okay. But we know it's a music database and it consists of information about music, genres, and all that stuff. Okay. So we want to analyze this SQL database using natural language, using LangChain and LangGraph. That's the goal. Compatible with LangSmith Studio for debugging. So now it's saying it's also compatible with LangSmith Studio. Okay. Now we import the standard libraries again, packages. So LangSmith community from utilities, we are importing SQL database to connect to the Chinook DB. We are importing the code tools to define the tool and all from LangChain. From LangGraph, we are again getting the runtime. So LangGraph is getting runtime. LangChain agents, we're importing the create underscore agent, which is what we are going to use to create the agent. Okay. So the first step is we need to define the API keys. Okay. So here we are defining the API keys directly over here in the code, but ideally you have to define them in the .env file. Okay. So if you have an .env file over here, you have to directly define them over here. But it's okay because it's just a demo. We are doing this, but production, people will put them in the .env file. So, and then you load it from the .env file and then use it. But here for the sake of understanding, we'll just put it over here. Okay. So this is OpenAI API key, which we have. It is a paid key. You can also change this entire code to use only your code if you want. That's fine. Okay. I mean, your own model. You can use Gemini also. Okay. So next we have the Langsmith API key. So Langsmith, what we did is we went to langsmith.com and there you can request for an API key. You can go to settings and you can request for an API key. You will get an API key from there. Okay. Now, Langsmith Tracing and Langsmith Project, these are the names of the projects and everything. So because of this key and you say tracing is true and you're giving this project name, you can see the details of this particular project over here. Correct. So if you can see here, LangChain Pi Essentials. Correct. That's what we gave over here. That's where it's coming. So typically, if you go to the home of Langsmith, this is how it looks. And then it's saying observability for this particular project. So we're selecting this project here, LangChain Pi Essentials, and there's where it's showing the traceability for that particular project. So whatever is coming over there, it is going to show you. Now you can see that this particular project, right? I call it LangChain Pi Essentials. This is that project, LangChain Pi Essentials. Now here you are seeing whatever queries are coming, every single query that comes to your particular agent, everything will be logged. Okay. So it gives a lot of detailed information. Like for example, you can see the latency also over here, correct? 10.62 seconds is what is taken for this particular query to get responded for this agentic query, correct? Then this is 23.46 seconds. Okay. Now you can also see how many tokens are being consumed. So this particular query has consumed, like for example, this is the two different queries, right? So I'll just expand this. So this is the which table has the largest number of entries, and this is which table has the largest number of entries, correct? Now, although the query is same, again, it has done multiple iterations or something, and it has taken more amount of time. And these are the costs involved in making these calls to OpenAI. Okay. So again, these are the base of tokens, and that's how it is getting the data. We'll come into the details of this soon. Now, before we go there, this is about Langsmith. Okay. Next thing is we are also setting the Langsmith date keys over here. Next is define the context structure to support dependency injection. So we are defining the runtime context, okay, in a class, and in that context, we are defining the SQL database. Okay. So we're saying DB SQL database, and where are we getting this DB SQL database? We are importing from LangChain community. Okay. So first we will import the database over here. Okay. So we are importing the database from URI. We are saying SQLite Chinook DB. Okay. So whatever file we have over here, right, Chinook DB, we are accessing that file over here. Okay, using SQL database what we imported. Okay, and if we store it in DB. Next, what we are doing is defining the SQL execution tool. So I said whatever is with @tool is a tool definition. So in this tool definition, we have only one tool, which is execute_SQL, which accepts one parameter, which is str, which is the query of the user. Okay. So the docstring is saying execute SQL command and return results. This is what we saw some time ago. Now, what is the runtime? Runtime is saying get runtime context, what we defined above. Okay. And that runtime context has the DB, correct? And that DB is basically passed on to the DB variable. So this particular tool is getting the context of that DB handler, that connection. Okay. So that it can execute that query, correct? Because this tool might not have that context. So it is getting the context of the handler to the DB and executing the query on that database. So this tool does very simple thing. It takes a user query and it takes a query and then executes that query. That's it. That's all it does. Okay. But who's giving this query? This query is a database query. Who's giving this? LLM will give. And I'll show you where. Next, we have a system prompt. In system prompt, we are saying you're a careful SQL analyst. Think step by step. When you need data, call the tool execute SQL with one select query. Read only query, no insert, update, delete, and all that. Limit to 5 rows. If the tool returns error, revise the SQL query and try again. Prefer explicit column list, avoid select star. Okay, so this we already saw. Next is creating the agent. So here we are creating the agent, which is OpenAI GPT-4 mini, so that we can reduce the cost. We don't need a big, powerful, model. Simple model will do, mini. Next is tools. We have only one tool, which will be defined above, execute_SQL. Okay. Next is system prompt. This is what is the system prompt we defined. We're passing that also. And the context schema is runtime context. So which we defined above, runtime context. So the funda is this particular agent, what we are creating is the final agent that is used for our purpose of running, getting data from the database by using simple NLP queries or natural language English queries, natural language programming queries, correct? So this is the main function, the main def main, okay? The main function run the SQL agent, okay? Initially, when you run it, it will again print all the statements. So it has an example query to start with. Which table has the largest number of entries, okay? Now, so far we have realized that we have a database called Chinook.db. We don't know what tables are there, what schema is there. We have absolutely no information. Okay. But we are asking a simple question, which table has the largest number of entries, right? How will the agent get the information? Correct. So like I said, so we'll go into the details. Okay. Now here the logic is saying that in main, if I have a questions array, okay, and for each question, like I'll loop it through the array of questions which are there, and I will run this agent.stream, which is going to say, okay, do one thing, go and take this and get me the response for this particular question that is there in this array of questions. Okay. Now here we are again just putting some commands and all these things. So while it is true, we are going to now make a an agent call. So one second, is that? Yeah, so we are saying agent.stream, right? So agent.stream is basically saying if they execute the agent with whatever request that is coming in, correct? So there is a thing. Yeah, this is the question that the user has asked, right? So send this into the agent.stream. Okay, this is within the same thing. Okay. And what is the context are we sending and what is the stream mode? That is the values. Okay. So once the agent gets the information, that is a user question. Okay. The user question is, where is that? Array. Yeah, which table has the largest number of entries? The first thing that happens is the agent takes this particular question and passes it to the brain, which is the model. So the model will take that question and it will say, okay, user is asking which table has the largest number of entries. So what will it do? It will first try to identify which tool is the best. Here we have only one tool, but if we have more tools, it will decide which tool is the best tool to execute. And the decision is made based on the docstring. Okay, so here the docstring says execute a SQLite command and return the results. So here, since there's only one tool, anyways, it will execute this particular tool. Okay. Now the challenge is that this particular tool only accepts an SQL query. It does not accept general English. Correct? Because if you take this particular thing and go and hit the DB, you will get an error, right? Because you're asking a general query called which table has the largest number of entries. Correct? Now, what we need to do, this English text has to be converted into a database query. Okay, so to convert it into a database query, what should it do? It should first get the schema from the database. Schema is what are all the tables which are there in the database, and then see in each table how many entries are there, and then based on that decide it. So how does it happen now? How does all of this happen? Okay, all of this happens basically on the fly because we said that if a tool returns error, then revise the SQL and try again. Okay. So now what we'll do is we'll try running this particular query and we'll see how it works. Okay. So first I'll say Python LangChain code. So if you can see this, it is basically here what we are seeing is which table has the largest number of entries. You can see this is the question that we asked in this here also, correct? Which table has the largest number of entries? So that question has then been, and you can see the human message here. Okay, this is a human message, and then there's an AI message. Okay, so the AI message is basically documenting in detail. This is the two calls. The first tool call is execute_SQL. Okay, and the call ID so and so, and the args are select name from SQL master where name type is equal to table. Okay, so what did it do? It dynamically created a query called select name from SQLite master. Why? Because it wants all the names of the tables. So type is equal to table, right? SQLite underscore master, where type is equal to table is going to give all the tables names. So if you can see here, it executed that, and these are all the tables which are there in the database. So album is one table, artist is one table, customer is one table, employee is one table, genre is one table, invoice line, media type, playlist track, and track. These are all the tables which are there in the database. Okay. Now, what was the question? The question was which table has the largest number of entries? Now, just by knowing the table names, you cannot know which table has how many entries, correct? So you should know each table, how many entries are there. Okay. So what we should do for each table, we should again make separate queries to each table to know how many entries are there in each table or how many rows are there in each table. Okay. So once that call is made to each table, then we will know how many count is there, and then we can know which table it has the maximum entries based on the counts of each of the tables. Okay. So if you see, it makes one more tool call. Okay. So if you can see now that it has all the names, it makes another tool call. So this is the React, what I was talking about, re and act. Okay. So this is what we are talking about when we say it can do multiple iterations. Okay, so can you see this now? It's not saying select count star as count from album, select count star as count from artist. So can you see this? For everything, it is making separate calls to each table to find out what is the count of each one of them. Okay. Clear? Any questions here? Any questions, anyone? So we are dynamically calling this count from each table, and then once we get the counts, then we make a decision. If you see here, okay. Now here are the counts for the entries for each table. Can you see this here? It is individually printing. Okay. So album table has 347 entries. Artist table has 275 entries. Customer table has 59 entries. Employee has 80 entries. Genre has 25. Invoice has 412, and so on and so forth. And then it is saying the table with the largest number of entries is playlist track with 8715 entries. Okay. Which is correct, right? Because if you see all the tables over here, the maximum is playlist track with 8715 entries. So what has happened in this? The agent got a simple request, which is which table has the largest number of entries, and the agent is able to find out an answer by dynamically constructing the query by first fetching all the tables and then constructing queries for counts of all the tables and then deciding which one has the maximum thing. So this is the purpose of agents, right? This is how agents work. Okay. Now we can ask another question. Any question here? Anyone? Anybody has any questions still here? Now, if you see, the whole code in the file is also not much, right? There's not a lot of code in the file. Just with this much, only like 120, 130 lines, you have built an entire AI agent. Got it? And you can always control the behavior of the agent by just updating the system prompt. Okay, we'll try doing some modifications to the system prompt and see how it works. Okay. So anybody, any questions? Okay, so let's ask one more type of question now that we have some more information, right? If you see here, the table with the largest number of entries is playlist track with 8715 entries. Okay, so let's say I ask a question, playlist track, right? Show me the top 5 records in the playlist track table. Okay, now this is the human message, if you can see. So I'll just zoom it out. So the human message is show me the top 5 records in the playlist track. Okay. And the SQL query says select star from playlist track, limit 5, and it's able to directly get the data out. Correct. Now, how did it do this? Because I explicitly gave the name of the table. Okay. I said, show me the top 5 records in the playlist track table. So it directly executed it and it got the results. Okay. So it's a simple text to SQL kind of a query and it's fetching the results. Isn't it powerful? Now let us try to do something more interesting. Show me top 5 record of the playlist tracks rep table. Okay. I said S extra by mistake. Okay. So what happened? Now we know that there is no table called playlist tracks. So there is only a playlist table. So playlist track table. So since we gave error, it says select star from playlist tracks table because it assumed that I gave the correct table, but it got an error. Okay. Now because it got an error, right? What is it doing? It is again trying to make a call, select name from SQLite master where table is type is equal to table. If you see this, it automatically went ahead and made a call to the SQLite underscore master table to get the names of all the tables from the schema again. Okay. So it got all the names of the tables again from here. And then it said query select star from playlist track where limit 5 and it got the 5 records. Okay. So here are the top 5 records which it got from there. And this is the beauty of an agentic AI kind of an application, right? So here what's happening is although my query was wrong, it dynamically went ahead and made a change to that and it directly went ahead and got the list of tables, correct tables, and then queried it. Now this is happening because in our prompt, we have something over here which we mentioned called if the tool returns error, revise the SQL and try again. Okay, that is exactly why it is behaving like that. Now, what we'll do is we'll try to remove this. Okay, we'll try to remove this and see what will happen. Okay, so let me do one thing. I don't want to type it again. So let me see if we can comment it. Okay, or let's not do that. Let's just copy the system prompt. Okay, and okay. I'll just edit it by removing this particular line. Okay. Now remove that line where I said iterate it. Okay. So I remove that and I'm going to restart the agent. Okay. And let us see if it is going to do that iteration again. Now here it is saying it is okay. Now it's running this. Yeah. Now let's ask the question again. Get the top 5 rows from the playlist tracks table. Okay. Let's see what it will respond. See, can you see this? It says that it looks like there is a table named playlist track, but not playlist tracks. Would you like to retrieve data from the playlist track table? Okay. So why is it explicitly asking it? Correct? Why is it explicitly asking it? Because we did not explicitly tell it to run it. Now let's look at the system prompt again. Okay, if you look at the system prompt here, we are saying if the tool returns error, revise the SQL and try again. Right? This is the extra line which we remove. And the reason why it was giving us results earlier on was because it was reiterating it and correcting the table name to play this track, and then it took that extra effort of getting the result. Got it? So that is the power of the system prompt for the agent. Whatever you tell it that is what it will obey. Okay. So that's why it's important to set your system prompt very strong. The entire AI agent is dependent on your system prompt. Okay. So if you want guardrails or if you want anything that's really tight, then you should make sure that your system prompt is really strong. Okay. Any questions, Leo? Anyone? Then we look at how LangSmith works. Any questions, Leo? Are you all clear? Are you following what's going on?
Yes, sir.
Okay, great. Now that you know how the AI agent works, now let's look at LangChain or LangSmith and see what's happening over there. Now, when I ask a query over there, right, if you can see here, it is entirely recording all the details that is coming in from there. Okay, so here when I click on this, you know, yeah, when I click on this, you can see that the entire trace, right? Get the top 5 rows from playlist tracks table. You can see this. This is the question I asked most recently. Now, the human query, so basically, again, if you look at it, the terminal is very difficult to read, right? So it's so hard to see what is going on, where is what happening. The terminal is all black and white and it's all very not so easy to read. So that's where you have something called LangSmith, which is observability for LangChain based projects. So this will come basically because we are providing an API key. Okay, so we are, like I said before, we have an API key over here of LangSmith, which we are providing, and that's the reason why it's connecting. We also specify it's true and also give the project details. So that's why it's connecting all the information from there and showing it over here. So the human question what I asked is get top 5 rows from the playlist tracks table. It executed it. It shows the exact query. Can you see this? Select star from playlist tracks, limit 5. It shows exactly what's happening under the hood. Okay. So if I'm having a tool, what is happening? What request am I getting? Can you see this? This is the exact query which came. It got an error. It seems the playlist track does not exist in the database. Let me check the available tables to see which ones are present. So AI is telling this one. Next, again, it made a query. Select name from SQLite master, please go to table. And then it executed, it got all these tables. Now, because it got all this information, the LLM again made a decision to say, okay, I don't have explicit instructions to execute, but I will present the user with an option to make a choice based on the fact that these are the tables which are there. Now, based on these tables, it will tell that, hey, user, I have found a playlist track, but not playlist track. So what do you want me to do? Okay, so that's exactly how it works. Now, if you see in detail, that's the entire LangGraph flow, correct? Now you can see what's happening on the model side. Okay, so each one of them will again yeah. So again, each one of them will talk about what is happening in their respective layer, what's happening in the model layer, what's happening in the tool layer, how are the interactions happening, everything will come in detail over here. Okay. So you can also go ahead with the waterfall model. Can you see this? So this is a waterfall model where basically we are saying multiple iterations happened. The first iteration happened when it said, hey, tell me the details of what request you went. So you can see this. It says select star from playlist tracks, limit 5. Okay, that's the first query. So then you have a response from the ChatGPT OpenAI. Okay, can you see this? So the request from the model, right? Basically, again, from the LangChain application went to ChatGPT, and this is the prompt that went to ChatGPT. Can you see this? It is not saying that you can iterate it if there's an error, right? Because we removed it from the system prompt. Okay. So this is the exact system prompt that has gone to ChatGPT, OpenAI API, and this is a query that has gone. So what goes in an API? Typically, the system prompt goes and the human prompt or the request goes, and then it gives a response. Okay. So what is the response that it gave? If you can see, this is the exact response that came out from the ChatGPT. Okay. So ChatGPT gave a response saying, the query that you should execute based on your user query, which is get the top 5 rows, and the system prompt is this one. So this is what is the response from the LLM back to the model. Now, what did the model do? The model said, okay, I got that particular response from ChatGPT. Now I will execute it. So it made a call to the execute SQL tool. So you can see this. It made a call to the execute SQL tool with that query which came from OpenAI, which is select star from playlist tracks limit 5. Now, what did the tool say? The tool said, oh no, I have an error, right? Operational error because no such file, no such table playlist tracks. So it will also print out what is the exact query which came to that particular tool. Okay. Now, what is the output? So it seems that the playlist tracks table does not exist in the database because it saw that we got an error. Let me check the available tables to see which ones are present. So the LLM decided that it will make a call to decide which tables are there. Now, if you see the OpenAI call, what was made, right? See, if you see the OpenAI call that was made, it is saying the output for that is select name from SQLite master where type is equal to table. So what did OpenAI say? Do one thing, just go and make a call to this particular SQLite master to with type is equal to table to get all the names. So then you can do the next operation. So what is the next operation it did? It then went ahead and again, this is all the chain of thought. It went ahead and executed that. So once it executed through the execute underscore SQL tool, it got a response of all the tables. And then what it did is it analyzed it and said that, of all these tables, it looks like playlist track is the most closest table. Okay. So if you can see, this is how it kind of responds. Okay. Make sense? So this is how it's responding, saying that it looks like there's a table and it got it out. Okay. So again, LangSmith is basically used to kind of help us with getting to know how, see, this is the chain of how the execution is happening. Anyone?
No, sir.
Okay. Is it clear so far? Are you able to follow? Or is it
Yes.
Vishwas?
Yes, sir.
Yeah, Vishwas, are you able to understand what's going on?
Yes, sir.
Cool. So now is it interesting?
Yes, sir. It's interesting.
Yeah. So I would like you to follow through, and you can also use ChatGPT to kind of give you a simple LangChain project for this one itself. It will give you the exact steps, and you can follow. Okay.
Sure, sir.
Yeah. Anyone else? Any other questions? So again, if you see here, the power of the whole thing lies in the system prompt. Okay, so system prompt. So that's why it's easy that's why people say that the next generation of programming languages is English. Okay, so English is what is going to control how we are going to kind of communicate with the models, how we are going to build applications. So here, if you see, we are really not controlling anything much more than uh, just writing plain English. I just removed some line and it gave something else, and that's how interesting it has become now, right? Cool. So now, apart from this, again, now that we have some more time, so what we can also do in this, okay? See, so what we'll do is first thing is we'll restore our system prompt because I wanted to uh, restore make iterative calls. Okay, I'll restart my agent. Okay, when I restart it, it automatically makes a call because there's a question already loaded in that. Okay. Uh, okay. So let's ask a question saying, tell me about the capital of India. Okay. So what do you think will be the response? Can someone tell me what will happen when I say tell me about the capital of India? Can someone tell me what will happen?
It will say like you can ask me SQL queries like that.
What will it say? You can?
Ask me questions related to SQL or the database.
Okay, you're saying it will say that, sorry, I don't know this. You can ask me about SQL or something like that. Correct? That's what you're saying.
Yes.
Okay, but then before also I did not ask SQL queries, right? So again, I know I asked a question saying, "Tell me about this thing," right? But let me ask a simple question also, right? Before this, let's ask a question which is, I mean, I know we asked a DB specific question, right? Let me ask some question saying, which playlist has the highest? Which show me the genres, right? Show me the details of the which genre, okay, which genre music is being listened to the most. Okay, so let's see what it comes up with. So can you see this? So it is trying to, we ask which genre is being listened to the most. It does not know which table to call, right? Because see here. Now what we can do is we can go to Langsmith and observe what's going on. Okay. So as soon as I make a query to that, you can see the query is already coming here. Okay. So which music genre is you listening to the most? You can see here. So this is a query that has come and you can see it already has multiple hits coming in all the way. Now there's one more hit happening here. So continuously it's making calls. Why is it making continuous calls? Because it doesn't know which query it is. So first it tried to say select genre count star as from music listening. So it is just guessing. Okay. So when I say which genre music is being listened to the most, it's just making a guess. But is there a kind of a table called music underscore listenings? Not really, right? We don't have it. So then what it will do, it will get an error, right? So it will execute it and it will get an error. And because it's getting an error, see, it got an error. See, no such table music underscore listenings. Now, because it got an error, then it again will iterate it. Okay. So it will again iterate it with a different query. So operational error, listen count from listenings. It tried listenings as another table. So it is going on trying this. Why is it trying so many times? Because we gave it in the system prompt, correct? In the system prompt, we said that if you don't have it, then please revise the SQL and try again. So that's why it's going on making multiple tries. Now imagine every time it's making a call to OpenAI, right? It's always costing us money. Okay. So we should be cautious whenever we say that because it can continuously keep iterating and continuously keep on making calls to the OpenAI and that will cost us money, right? See how many calls have been made here. A lot of calls, correct? And I think one more call is also being made. Or let's see what happened to the final status, right? See again, it appears that I don't have access to any relevant tables containing music listening data. So it is not able to figure it out. Okay. So let's see if we can make a slight change saying that revise instead of revise the SQL. See what it tried is some random tables, but what it should have done, try to get the schema, correct? Returns errors, revise the SQL by getting the list of tables from the schema and picking the appropriate table for the query and try again. Okay, so let's see if this works. Okay, what I'm trying to say is don't just randomly keep doing it. If it gets an error, try doing this. Okay, so we'll run this LangChain table. Again, this is a default table, so default query. So it is going to execute this. Let's complete this. That's okay. Okay, so this I actually we can just keep the array is empty, but it's okay. Now, which genre is more listened to by the most? Okay, so now if you see, it got an error because music listenings came. Now, can you see this? It made a query, right? It made a query to get all the tables, and then it selected the particular table because out of these tables, it figured out which table has the right information, and it is genre name or genre name as genre dot name as genre and count of tracked or tracked is listener count from track. It joined both these tables and got the data out and it answers this question. Can you see this? Isn't that beautiful? Right? So earlier it just gave up, but now it has got the results because I updated the system prompt. Cool. So that's the power of your system prompt. If you can tell it exactly how you want it to behave, it will behave exactly the same way. Okay. So that's it, folks. Any questions?
Sir, if it is possible, can you share this code?
Share the code.
Yes.
Yes, yes, I can share this code. What I'll do is I'll create a GitHub repo of this, and I'll do one thing, or Okay, I'll put it into GitHub repo and I'll put it in this PPT, and the Data Valley team can share the PPT with you. Okay?
Okay, sure, sir. Thank you. Thank you so much.
Sure. Okay. Fine. Okay, thanks everyone. Take care. Any questions? Yeah. Thanks all. Thanks for your time. Okay, Data Valley team. I'll share the PPT. You can forward it to them.